Hey guys, and welcome to the Chemistry Shack. In this video, we will be synthesizing trichloromethane, which is more commonly known as chloroform. Before I get started though, a quick disclaimer. Chloroform is flammable and also toxic. While the way it's portrayed in movies and TV shows is pretty exaggerated.
Consuela, does this rag smell like chloroform?
No.
It's still not a good idea to be breathing chloroform vapors. This video is for educational purposes only, and the procedure should not be repeated without an understanding of the risk involved. This synthesis is actually fairly simple. All we need is bleach and any methyl ketone. I'm using acetone, but you could use methyl ethyl ketone or pretty much any other methyl ketone. I'm doing this on a 3 molar scale based on acetone, so I am using 2 liters of bleach. From each of the bottles, 150 milliliters of bleach is removed so that we have room to add the acetone. The remaining bleach will give us a 5% excess of sodium hypochlorite, assuming the concentration of the bleach is actually 8.25%, which is what is listed on the label. Excess sodium hypochlorite will ensure that all the acetone reacts, because acetone will be very difficult to remove from our chloroform product. If you have excess acetone, when you try to distill your product, the acetone will distill off with the chloroform in an azeotrope, making it very difficult to remove. Anyway, once the 2 bottles of bleach have been allowed to cool to below 0 degrees Celsius, the acetone can be added. In total, 3.02 moles of acetone was measured out. This was added in 2 separate portions, each weighing 87.7 grams, or about 110 milliliters. Once the acetone was added, the bottles were capped and shaken thoroughly. This reaction is incredibly exothermic, and that's why we needed to cool the bleach to below 0 Celsius. Even though the bleach was cooled before adding the acetone, after only 10 minutes the temperature had already reached 50 degrees Celsius. After shaking, the caps were placed loosely on the bottles to prevent any buildup of pressure. While we wait for the reaction mixture to cool and for the chloroform to settle out, let's look at how this reaction works. In this reaction, 1 mole of acetone reacts with 3 moles of hypochlorite ions from the bleach. This produces chloroform, acetate, and hydroxide. This reaction is known as the haloform reaction because it produces a haloform, which is basically a methane molecule where 3 of the hydrogens have been replaced by a halogen. As the reaction progresses, you can see the solution becoming white and cloudy due to chloroform in suspension. As a side note, this is a good demonstration to show why you should chill the bleach before adding the acetone. In this case, the mixture got hot enough to boil the chloroform produced. This would ultimately lead to a loss of yield and also a lab full of chloroform vapors. Another interesting observation in this reaction is that the yellow-colored hypochlorite ions convert to colorless chloride ions. Anyway, after a while, the chloroform settles out into a blob on the bottom of the beaker. So now let's go check on the actual reaction mixture. After letting the reaction mixture sit for about 45 minutes, the majority of the water can be decanted from each beaker. This water has traces of chloroform in it and should not be flushed down the drain. In the video description, I discuss how to dispose of the waste. After decanting about 3 liters of water, the last remnants of the bottle contain our chloroform. The chloroform from both bottles was transferred to a separatory funnel and allowed to settle. After settling, the top layer contains water as well as all of the reaction byproducts and excess sodium hypochlorite. The lower layer contains our chloroform product. The lower chloroform layer was drained off and the upper water layer was discarded. The lower chloroform layer was then added back into the separatory funnel and dried using a saturated solution of sodium chloride. The layers were mixed well and then allowed to settle. The lower chloroform layer was drained into a flask containing calcium chloride, which serves to further dry the chloroform. After sitting over the calcium chloride for a few minutes, the chloroform is essentially crystal clear, showing that we have removed most of the water. A simple distillation is carried out to recover the chloroform. The chloroform is the first fraction to come over between 60 to 62 degrees Celsius, which is consistent with the literature boiling point of 61.2 degrees Celsius. The distillation proceeds very rapidly, and pretty soon it's all over and we're left with 162.87 grams of crystal clear chloroform. It's a bit strange to look at because it has such a high index of refractivity compared to water, so it severely distorts the objects in the background. Anyway, this represents a relatively low 45% yield. The yield could be improved by adding the acetone dropwise to the bleach while maintaining the temperature below 0 degrees Celsius. However, even with this low yield, this procedure produced over 150 grams of chloroform for under $10 worth of chemicals, so it's already pretty effective in terms of cost, and trying to improve the yield would be an unnecessary hassle in my opinion. After the chloroform was added to a bottle for storage, 1% by mass of methanol was added, which in this case was about 1.61 grams. The methanol stabilizes the chloroform and prevents the formation of toxic phosgene gas. Absolute ethanol could be used in place of methanol. The bottle was wrapped in aluminum foil because chloroform is sensitive to light. Well, that's it for this video. Make sure to check out some of my other videos, and if you like what you see, go ahead and hit that subscribe button. Thanks for watching!